Hey folks, this is me, Vishwasna, and I'm the host of this podcast. A lot of times DevOps is changing. It's the agility that this industry has brought on the table. The adoption is happening in a way more quicker fashion, and the principles of DevOps are changing. I think Viktor Farcic is one of those people that industry looks back at in order to not just refer to tools or technology, but also for right practices. He has seen a lot in the industry and he himself has evolved as an engineer. And it's an honor for Devtron to celebrate leaders like him in order to give you that right insight so that you have the best practices for the tomorrow's world. And Victor, thank you so much for being on the show. Means a lot.
Thank you for having me.
Sure. Let's start with this question. There's been a huge hype about what DevOps was all about. Hey, you know what? DevOps is this, DevOps is that. But I wanted to know what was your first introduction to the world of DevOps? And how is this world changing with respect to the adoption of DevOps in every single aspect? What we can think about in terms of adoption, in terms of scale, whatever it is.
Yeah, I mean, it's close to impossible for me to answer that question because whenever somebody says DevOps, that somebody means something else. So when people ask me, "Hey, what was your beginning in DevOps?" I don't know. Let's talk about what DevOps is, right? So if let me provide two commonly used definitions without saying which one is right or wrong, right? Majority of people I speak with either say that DevOps is about me using some tools and doing something, sometimes related to automation, sometimes some other people would say, hey, I'm using Terraform to manage infrastructure and so on and so forth, right? If that's what DevOps is, and that's usually associated with the term DevOps engineer, right? It's that if that's what DevOps is, then my introduction to DevOps happened some 20-something years before we heard the term DevOps, right? Because, hey, I've been using CF Engine. Probably most of the people looking at, listening to this, never even heard about CF Engine. That's, before Chef, before Puppet and stuff like that. I've used Jenkins the moment it appeared, like some almost 20 years ago, right? So if being DevOps engineer means, hey, I'm using some tools that are not typical developer tools, and I'm doing something with those tools, then, hey, I'm a DevOps engineer for the last 30-something years. Now, if you define DevOps that, hey, it's about joining development and operational knowledge and experience into a single team that is capable of doing everything related to an application, from having an idea all the way until it is running in production and being able to do that themselves, then that happened a bit later, at least in my case, right? Still, before we invented DevOps, I was trying to help people how they can do things themselves instead, because I'm lazy. I don't want people to send me an email, can you do this for me? I don't want to do that. I never wanted to do that. So a while ago, right? I don't think that DevOps really introduced much of anything new except confusion. The only good thing, the main good thing about DevOps, I believe, is that it put at the forefront certain problems that many companies did not see as problems, right? That isolation and not working together and so on and so forth. I'm old, so sometimes I might forget your question, so I don't know whether I'm even answering it.
Sure. You answered that question. You answered that question in two different perspectives. Like it's not just tools, it's not just technology, it's also about people, process, and everything. So now coming back to the open source software and the adoption that's happening in the world, some people are really skeptical about it. Like they think, you know what, enterprise is the new grade, and somewhere down the line, organization still doesn't strategize OSS adoption. So how to overcome the barrier of OSS adoption, and how can industry evolve with respect to an open source adoption as one of their key factors today?
So let's start by sending a message to everybody who says, hey, I don't want open source, I'm using enterprise. And I assume that when you say enterprise, you mean not open source, right? Such a person, such a team does not exist in the world. there is not a single company on a whole planet that I know of that is not using open source. Because, hey, you have servers, right? What are your servers running on? Linux? It's open source, right? You write code of some of your application, right? You import some libraries, like for logging, for this or that. What's that? Open source, right? So everybody is using open source. There is absolutely no question about that. The only differentiator really is whether you pay some other company or companies in plural to give you additional features on top of open source and support and help and so on and so forth, or you don't, right? But you are using open source. There is no company that is not using open source. You might not know that you are using it, but you are, right? So that would be like, hey, I can go with Ubuntu, right? Or CentOS, or I can use RHEL, right? Red Hat. Now, both are open source. It's just that behind RHEL, you have a company that will help you out for a fee and will ensure certain things, will fix issues when they happen, and so on and so forth, right? Now, if you're using pure open source, meaning you're not paying anybody for the open source software that you're using, then you're on your own, right? You can a while ago there was that problem with Log4j, right? The vulnerability, stuff like that, and people crying, "Hey, open source is horrible. Look at the vulnerabilities." And it's not that it's horrible. I mean, first of all, you have vulnerabilities everywhere, but more importantly is that, hey, you've been using it for free. You never contributed back, and now when there is something wrong, what do? You scream, you cry? No. If you want to use open source for free, which is completely valid, most of the stuff I use is open source. I'm very big on open source, but then you need to be prepared to say, hey, I'm not paying anybody to fix problems for me. When problems come, what do? You create a pull request, you fix it, right? So that's really the question. Do you want to work on it yourself, or you want to pay somebody else to do it for you? But in both cases, you're using open source.
I think you have seen different scale. I think you have seen different components of how scale was. So now my question is all about like, what are the challenges that every organization need to think and rethink before they say Kubernetes adoption in their production? And also, what are those key factors that they need to really reimagine in order to get that right adoption into their production? Because not every production is ready for Kubernetes, not every SDLC is suitable for that. But what should an organization rethink, and what should they actually reimagine while adopting Kubernetes?
There are quite a few things, quite a few, and I'm almost certainly going to name only a few, not all of them, because the list could go, we could speak for hours now only on that subject, right? But to begin with, one of the main obstacles is that if you do things right, you design your application in a way that is suitable for the environment you're running it, right? So when we had mainframes, we were designing applications in a certain way. When we started running it on bare metal, we designed it in another way, and so on and so forth, right? Now, you can put anything in a container. But if you just put random stuff in a container, you're in a lot of pain and suffering, and the return of investment is going to be negligible, right? So the first thing people should consider is whether this is a suitable application to run in a Kubernetes cluster. Anything can run, but the benefits, if you say, hey, if the benefits for a microservice are 100, whatever the imaginary random number, then for a WebSphere running application running in Kubernetes, the benefits are 3 or 17, right? Much smaller than the return of investment is much smaller than if you run something that is designed for Kubernetes. And when I say designed for Kubernetes, that's actually not the right expression. Designed to be cloud native. What I would recommend to everybody is to Google 12-factor apps, right? That's a list of 12 factors. I think that Heroku came up with that. that if you fulfill most of those 12 factors, you're well suited to running Heroku back in the days, right? But that's equally valid today for Kubernetes. So think about architecture and whether your application would benefit from Kubernetes itself, right? If you cannot scale it up, probably not beneficial. If you cannot upgrade it and during that process be moved to somewhere else, not beneficial, right? So think about whether it's worth it. Not all applications are good for Kubernetes. But to me, that's the lesser of the problems, right? Bigger problems are cultural and process-wise, right? When we compare Kubernetes to what most people were doing before, even though you were not forced to do it, is that we see in the past something much more static and now something much more dynamic, right? In the past, if you ask a person, hey, where is this application running? That person would tell you, oh, that's on server called Unicorn, right? There is a server, we even give it a name, and that's where that application is running, right? Now, if you ask somebody, hey, where is my application running that is in Kubernetes? The answer is, I have no idea. And if I find out where it's running on which server in a cluster, by the time I tell you, it will already be somewhere else, right? So it's moving, it's dynamic, it's ever changing and evolving in a way, right? And the third big problem that I'm seeing is people being afraid to lose control, right? In the past, and by the way, everything I said for the previous point for Kubernetes, that typically applies in cloud as well. It's not specific to Kubernetes. Anyways, going back to control, right? Traditionally, historically, we're used to that idea that you are doing something, and you're in control of that something. Hey, I'm going to log into this server, I'm going to do this, and then I'm going to do that, and so on and so forth, right? You're performing certain steps, certain operations. And in Kubernetes, you're not doing those things. You cannot tell Kubernetes, do this, or do this at this specific moment. And after you finish doing that, do that, right? You're not doing that at all. Even though sometimes it looks like you are, but you're not. What you're doing with Kubernetes, you're specifying the desired state. You're saying, hey, I would like to have application based on this image running as 3 replicas somewhere. Right? And it sounds like it's almost the same, but it's not. It's a very huge difference between imperative, I'm going to tell you what to do, and declarative, where you say, I'm not going to tell you what to do, I'm going to tell you what I want to have. And then that people do not admit it, but that sounds very scary, right? Very often people ask me, hey, can I have something equivalent to Terraform plan with Kubernetes? Can I get information what will happen before I tell Kubernetes to do something? And the answer is no. Because Kubernetes, after you say, I want this, Kubernetes will spend 1 millisecond or 1 second or 1 minute or 1 hour or 1 week trying to make that happen, right? So I see it more like, if you think of roles, you have an ops person or sysadmin, right? Now with Kubernetes, you're less of that person, you're more of a manager. You know, a person that comes to your office and says, I do not know what you guys are doing, but I'm going to tell you that I want this to be done. I don't know how, I don't know when, I don't know why. I mean, you should know why, right? Good managers do. But you're instructing more what you want than how to do it. And it takes time until, kind of sounds easy, but it takes time until our brains are rewritten to follow that logic.
Sure, I think somewhere industry has moved more towards the low code and a no code approach, right? You know, everybody wants everything to be generated out in some or other form factor. And I think everybody is defining non-UI and a UI, low code and a no code platforms today. So somewhere, even in that effort, there are misconfigurations of cloud happening. It's happening somewhere down the line. So there is a perfect match that industry has to actually witness between a non-UI and a UI based application. in delivering accessibility and flexibility of giving that developer a right choice of, hey, you know what, you can still get your own configurations and you can still use the configurations which are already with respect to some standard. So how can industry really blend the gap between, or else fill the gap between giving the flexibility and accessibility with respect to a modern age solution that is low code and a no code platform?
It all depends really who the audience is. Like, if the audience is my mom, right, and she wants to create a website, I will never tell her, hey, you know what, you should install Visual Studio Code. You should spend 3 years learning HTML and CSS and JavaScript, and then a bunch of other things, and you're going to have a website, right? That's not her expertise. So instead, I'm going to tell her, go to WordPress.com, right? That's a sort of low code, no code, even though we don't call it like that, right? She can drag and drop and she can get the website, assuming that she doesn't want to pay a professional to do it, right? She's going to get the website relatively quickly. Now, the simplicity of that, it comes at a cost, right? Because the website that she's going to create in WordPress.com is not going to be even close as good as if some professional who uses Visual Studio Code writes directly YAML and JavaScript and stuff like that, right? Builds, compiles, and does the things. It's not going to be as good, but it's going to be better than anything else she would do herself, right? So it depends really who the audience is. One day we will maybe all use low code, no code. I cannot predict that. I cannot predict anything more than a year or two in advance. Kind of nobody knows. But right now I see low code, no code more for people who need to do certain things that are outside of their core competency, right? So if I'm HR, instead of me bothering you now and paying you, giving you money to create the application that I need for HR, I can find a low code, no code solution. I have what I need. It's not going to be great. It's not going to be perfect, but it's going to be much better than anything else I could do, right? And I cannot afford you to do stuff. And even if I can afford you to do stuff, you have better things to do, right? So it all depends. Same if I go now closer to our profession, right? Let's say that you're an application developer, you're a front-end JavaScript developer, right? You're most likely not going to use low code, no code to write your JavaScript, whatever, Node.js, and so on and so forth, right? Because the results are not going to be great. But you would like to deploy your application yourself. Now, that's an area where you're not an expert, right? You're not a person who knows everything about Kubernetes because it takes years to figure it out. So you want a button, click a button, and it's running in Kubernetes, right? So I think that's, in my head, low code, no code is more for the tasks that are outside of the core competency of a person today. In the future, it might evolve, right? By the way, I don't know if you know it or anybody remembers, like I think it was like 20-something years ago, I used Dreamweaver. One of the first websites I created was with Dreamweaver, drag and drop. I did not even know that you can write HTML and whatever was it back that time, right? It's similar like DevOps. It exists for a long time. We had those things for a long time. It's just that they're getting better now and better and better and better. And that's a great thing. And now we have the third thing, right? So we have people who are really proficient in something, not likely going to use it. People who are proficient in something, but they need some other type of tasks, they're going to use it. And then we have a third group of people that are, let's call them platform engineers, right? That are going to create solutions for others in their company to use, right? And that's a perfect match to me, right? I'm in charge of, let's say, managing infrastructure or it doesn't matter what it is. And I don't want you to continue bothering me to do things for you, right? So I have a couple of options. I can teach you Terraform, Pulumi, Crossplane, whatever you're using. That's going to take a lot of time. That's not an option. I can tell you run this script without knowing what you're doing. That's not a good option either. But I can create some kind of web interface, right? Or buy a solution, doesn't matter. Some web interface or CLI interface where you specify, hey, you remember those Jira tickets that you were opening for me to create stuff? You remember that in that Jira ticket, there were 6 questions that you needed to answer? Maybe I can provide those 6 questions as an interface to a service that I designed that will do whatever needs to be done, right? And that becomes an internal low-code, no-code solution, which is very attractive to me at the moment. We call it kind of platform engineering. Again, you can buy it, you can build it. There's anything in between as well.
Sure. I think SDLC is improving. Everybody wants to be a person who can really define a new definition in SDLC. I think somebody down the somebody down in the production, there is somebody thinking like, you know what? Let's think about changing a stack that we have today. Let's think about changing the way we think Kubernetes today and things like that. So now strategizing security is very tough because it's changing at a speed of light. I don't know what stack my company will be using tomorrow or anything. I still don't know that. So I wanted to know how is IT operations of strategizing and security in the ecosystem of software engineering that is changing, and how should world actually approach in strategizing security today?
I think that security might be, I think that almost all different segments of the industry, security being one of them, are going through the same phases. It has some parts of the industry improved earlier than others, and I think that maybe security is a bit lacking behind. And when I say being behind, I do not mean really on expertise that people have in that field and none of those things, but in terms of processes, right? Where we are right now, and where I think we are not there yet, but we absolutely need to get, and that's to shift it left, right? We cannot continue from the security perspective with the same practices before. And that practice was, okay, so you over there, you develop your stuff. You can spend weeks or months or years doing that, no problem. You just do it, right? And then when you're finished, I will go through that stuff and I will tell you how terribly wrong you are. And I will give you 5,765 vulnerabilities that need to be fixed, right? And then the third person comes in, manager, and say, hey, but I have a deadline. And then we forget about everything, right? So it needs to shift left. When I talk about security experts, I'm really mostly interested in how they can enable everybody else to do stuff in a secure way, right? Now, that's not a new idea. We've been doing that for a long time, but we've been failing big time, especially in security space, in other areas as well. And that failure is that you cannot just say, okay, shift left is now you do it. I need to enable, I need to give you tools to do it. And the tools cannot be the same tools as what you as security experts use, right? Because you understand that there are 5,000 vulnerabilities and you understand which are important and which are not important and which can be fixed and all that stuff, right? What we need is something very, very simple in terms like, hey, whenever you develop something, you push it to Git, there is some security scan, we already do that. But here is the part we don't do that commonly. And that's when there is a problem, I'm going to have a system that will tell you how to fix it. I do not care about people telling me that there is a problem. I know that there are problems. And the only thing you do accomplish when you tell me there is a problem is that you're depressing me. I don't want to be depressed. I don't want you to tell me the problem. I want you to tell me the solution. So I do not want to see the list of vulnerabilities. I want to see the list of solutions that anybody can apply to avoid having those vulnerabilities, whatever those solutions are. And that's where we need to focus. We need to focus on helping developers solve security issues.
Sure, I think that's the greatest, actually, a definition that I really wanted every developer to hear. I think through the Devtron community, I think we are celebrating a lot of best practices. I think rethinking security is something that I always wanted to build upon. So I think thanks for bringing such a great point. I think it was such a great podcast because a lot of times people don't address the fact that you do not need to overthink your SDLC and you do not need to rethink about scale. There are some simple technologies that can really help you in bringing that practice. And I think that's the whole point. Thank you so much, Victor, for giving this podcast. Means a lot. I think this is going to impact a lot of practices that are going on in the industry, and that's going to make them think, you know what, let's think simple. Let's not complicate the things that are already complicated. Thank you so much, Victor.
Thank you for having me.